Okay. Okay, see the next example, right? So determine the conduction state of an ideal diode. So we just assume the diode is in conducting mode or non-conducting mode, right? And this is the circuit of this example. Vs is 12 volt, Vb 11 volt, R1 is 5 ohm, and R2 is 4 ohm, right? So in this example, to do this exercise, first we assume the diode is not conduct, right? In the blocking mode. It's non-conducting mode. So we replace the diode by open circuit, right? And let's see the voltage across, right? What is VD? If VD in the correct direction, so our assumption is correct. Okay. Let's see VD in the reverse bias direction. In the reverse bias direction. Yeah. So with this circuit, right, the current will flow here. We can calculate for V1. What is V1? V1 is the voltage across this diode, right? If we get V1 in positive, it means VD will be negative, right? VD is 0 minus V1, right? With this assumption, with the blocking mode assumption, with this assumption, when the diode is not conduct, it means we get VD negative sign, right? And VD is 0 minus V1, okay? VD is 0 minus V1. Okay. If VD in negative side, the assumption is correct. Okay. So by this circuit, V1 here. So V1, we use KCL here. We can use K. V1 minus 12, V1 minus 11. Okay. So maybe this is also, if you understand with this equation, is also okay. So V1 minus 12 divided by 5 equal to V1, no, flow out, so plus, right? Plus V1 minus 11 divided by 4 equal to 0, right? Okay, this is the same equation, right? Same equation, right? Maybe just of different sign. Okay. Then we solve for V1, we get 11.44. So V1 is 11.44 volt here, and this is a positive, right? V1 is 11.44, so it's in reverse bias, right? The diode is in reverse bias condition, right? So the assumption is correct because VD is negative 11.44, right? So we this assumption is correct. So we don't need to check with another assumption, right? So if we replace the diode by short circuit, what happens? If we assume the diode is conduct, if we assume the diode is in conducting mode, and we solve the diode by short circuit here, what happens? This is 5 ohm, this is 4 ohm, this is 12 volt, and this is 11 volt. What we get the solution? We will get, we need to assume, because this is diode, right? We need to assume ID in this direction, right? Only one direction that the current can flow, right? But with this circuit, when you solve this circuit, you will get ID in this direction, right? If you solve for ID, you will get the negative side of ID. So this assumption is wrong, right? So the diode is not conduct. Okay, you can recheck this again as well. Okay, so the solution is this circuit. Okay, maybe check for some understanding. What happens if case A, if V1 is 0 and V2 is 0, so both diode is not conduct, right? So if V1 is 5 volt and V2 also 5 volt, both diode will conduct the current, right? Flow here, and we get V out, right? We can show V out by voltage divider, right? By voltage divider. And if V1 is 0, V1 is 0, V2 is 5 volt, so it's conduct only V2, right? Diode number 2. If V1 is 5 volt, V2 0, conduct only V1. Okay. So, if we apply AC signal to the diode, what happens? The AC signal is in sinusoid form. This is the curve of sinusoidal form across diode and load circuit. So with the diode, the current can flow only positive direction, right? Can flow only in this direction. So with this supply voltage, the current can flow. With the current flow in sinusoidal shape, we get voltage in the same form, right? Okay, but once the current start flow in reverse direction, the diode will block, right? It will block the current flow. So for the next waveform, it start to conduct the current. So you will get the output only positive side of. So VL will be in this shape, right? Only positive. We get only positive voltage for VL, right? We call this type of circuit as rectifier circuit. Okay, rectifier circuit. With single diode, we get half wave rectifier circuit. Okay, this is half wave rectifier. We can get full wave rectifier, so with some more diode in the circuit. Okay. So we can transform AC to DC signal. Okay. So rectifier circuit is the circuit that changes AC to DC circuit, right? AC to DC circuit. We call rectifier. And we have half wave rectifier. We can have also with full wave rectifier. With full wave rectifier, we can get this shape of full wave rectifier. Yeah. The circuit of full wave is something like this. With this circuit, we will get with this type of diode. We use 4 diode, we can get full wave rectifier. Only positive side come to VL. Okay, if you flow with this direction, yes, you flow in only this direction. From here to here, from here to here. We call full wave rectifier. That will give us the negative side to positive side. So This is a type of circuit that transform AC to DC source. Okay, AC to DC source. You learn about this? No? Yes. Okay. In the lab, right? You have done it in the lab. Okay. With this circuit also. Okay, now talk about the offset diode model. So for the offset diode model, the diode will have some small voltage across itself. It's about 0.6 volt. So we can use this model, the diode with voltage source in reverse bias. So the voltage across the diodes to conduct the current, at least it must be more than 0.6 volt, right? If we use this model, right, it means that the voltage across in forward bias must be at least more than 0.6 volt. Okay, just substitute diode by the diode with voltage source. Okay, therefore, for in the conducting mode, instead of short circuit, when the diode is conduct, we substitute diode by 0.6 volt, right, in reverse direction. And for blocking mode, we substitute the diode by open circuit, right? Open circuit. Here, let's do like this. So we can make it more realistic calculation, right? Instead of ideal diode, we make it more realistic. Okay, let's see this example. So we have diode D1. So we substitute, if we assume the diode is in conducting mode, we substitute D1 by diode with 0.6 volt with in opposite direction, right? In reverse bias. And here VB is 2 volt and R1 here 1 k ohm and R2 is 500 ohm, right? 500 ohm and VR, no, our V of the diode is 0.6. Yeah. Okay, so to determine the V1, the lowest V1 to get diode conduct, the lowest V1 that to get diode to conduct. Okay, this is 2 volt. It's not just 2 volt, but it would be 2 volt plus 0.6, right? So if to make the diode conduct, it's not just only 2 volt of V1, more than 2 volt, it needs to more than 2.6 volt here. Okay, the diode will conduct when only V1 is more than 2 volt or plus 6 volt, is 2.6 volt. Okay, of V1. Okay, now if we have more than one diode in the circuit, so how to determine this type of circuit? So if the diode have also the offset voltage of 0.6 and 0.6, so we substitute this circuit by offset diode. So the diode will be with 0.6 volt here. And then this diode 0.6 volt here, right? This is the diode model, right? 0.6 volt. So how to know that the diode is in conducting mode or non-conducting mode? Okay. Or maybe just one diode in conduct and one other one non-conduct. Okay. So there is four condition, right? That we have four condition. So for D1 and D2. So both non-conduct. D1 off, D2 also off, D1 on, D2 on, D1 on, and D2 off, D1 off, and D2 on. So how to know? So if the circuit is complex, we need to try one by one. So both off and see what happened. Okay? And both diode on and see what happened. Okay? If both diodes is on, we substitute by short circuit, right? By short circuit. And so if the current flow in the correct direction for both, this means this assumption is correct. Right? If not, we try open circuit for the diode, right? Open circuit for the diode and see what happens. If in the reverse bias is correct, right? If not, if some contrary condition happen, you need to take other condition, right? So in this case, we need to check for four condition. Okay, for four condition. So I leave this, checking your understanding, I leave this for you, right? The answer is both diode is conduct. Okay, for this example. Okay, finally, we get both diode conduct for this circuit. If you choose first, both diode is conduct. If you choose first, both diode is conduct, and you will get the corresponding solution, right? The solution you get the solution that current flow in this direction and this direction. So your assumption is correct. So you're lucky, right? Because we have four conditions, right? For single diode, we have only two. So if we choose one condition and we find that it's wrong, right? So another condition will be right. Okay, and we can recheck it again. But for four conditions, if you choose the correct one, it's okay, you're lucky, right? If not, you need to try for some other L, right? Okay, so more tasks to do. Okay, it's not difficult, but it's some more tasks to do. Okay, I think you understand, right? Okay. Oh, that is okay. So I leave this for you, okay, for practice, right? It's okay. So let's see, this is another example. Also, we have two diodes. So in this case, we use ideal model. So the different offset model. Offset is more practical, right? We will have the voltage across the diode. But for ideal model, we just substitute diode by short circuit and open circuit, okay? Ideal. Okay? So with this example, we have two diodes. Again, we can assume D1 off and D2 off, D1 on and D2 on, D1 on and D2 off, D1 off and D2 on, right? D1 on, right? So if we assume both diode is off, what happened here? So D1 off and D2 off, we get this circuit, right? No current flow, right? So it means the diode is block the current here. 10 volt, this is 3 volt, this is 4K, this is 6K, and this is block. This means we get VD1 in negative, and VD2 also should be in negative side, right? But what we get is in positive side, right? It's 3 volt over here, and this is 10 volt over here, right? So if we assume the diode is in non-conducting mode, the voltage across diode is forward bias, right? It's forward bias. So this assumption is wrong, right? It's wrong. Okay. So this is the wrong assumption. So if we assume the diode both conduct, what happened? Conduct. The current should be flow here, right? And then conduct. Okay, the current should be flow here with this direction. What happened? This is 6K and this is 4K and this is 10 volt. This is 3 volt. So what we can do is we just solve for this voltage first. This voltage will be V1. So in this case, V1 will be 3 volt because this is 3 volt here. This becomes single node, right? If it's conduct, this is a single node. So V1 is 3 volt. And what is the current? The current, this is 3 volt. The current would be flow in this direction, right? 10 minus 3. ID1. ID1 will be 10 minus 3 divided by 4K, right? This direction, right? And this is correct direction. And let's see with this 3 volt. With this 3 volt, if this diode it conducts, it means it's come in this this direction, and it should come down here, right? Down here. 3 ID2 would be 3 divided by 6K, right? 6K. Oh, so this is the, when we assume D1 on and D2 on, this assumption is correct here. Our proposed, right? The assumption is on. Okay. And the current flow this direction and this direction, right? For both circuits. Okay. Because 10 is higher than 3. Okay. No. So if D2 is off, D2 is off, maybe same solution. Okay. If D2 is off, in this case, if we assume D2 is off, I think no current flow from D2 because this would be flow only this direction, right? If D2 is off, we will get this circuit. If D2 off and D1 is on, right? And if D2 is off, volt, and this is 4K and this is 6K here, and this is 3 volt. We also have VD here. This is 10 volt. The voltage, this is V1. Voltage here is V1. We get V1 equal to V1 is 6 divided by 6 plus 4 into 10 volt, right? Voltage divider, and we will get the solution of 6 volt here. This 6 volt here. Okay. So in this case, the voltage at this point is higher than 3 volt, right? So VD is VD2, right? VD2 is negative 3. It's negative 3 in reverse bias, right? VD2 is in reverse bias. So in this case, the current cannot flow in this direction, right? It's 6 volt and this is 3 volt here. If D1 is conduct, okay. So the final solution is D1 on and D2 is off, okay, for this circuit. Sorry. So the assumption is D1 on and D2 is off, okay, and we get the voltage V1 6 volt here, okay, 6 volt over here, okay. So we just try for 4 conditions with 2 diodes. We need to try for 4 conditions, okay. Just try on, off. Let's see what happens. Okay, this is the homework for you. So only single diode, so you will try only 2 conditions, right? For each problem, okay? I think you can do it, it's not so difficult. And this is 9.21 is simple, but 9.22 maybe you find out the V1, V in to get D1 forward bias. Okay, maybe some complex problem for just for 9.22. Okay, what is the minimum V1 to get D1 forward bias? Okay. Okay, any question so far for diode circuit?